In this video, we're looking at how to solve quadratic equations using the factoring method, right? So in order to do that, what we want to do is follow the steps that I've basically listed up here in green. So these steps here will help us do the process of solving a quadratic equation when using factoring. So the first step is to bring all the values onto one side. Now, the reason why I know it's quadratic before I even begin is because it has this squared term here. That makes me assume that I have to solve it using a method that's suitable to get solutions for quadratic equations. Now, if we want to use factoring to solve a quadratic equation, we're going to bring everything over to one side. So I'm going to bring this 45x over to the other side. And remember, when I do that, what ends up happening is that it becomes a negative 45x, because when it crosses this little imaginary line, we change the sign of the value, right? So we cross the equal sign, so we change the sign of the number, or the coefficient of x. Now the plus 7 is here after that, and it'll be equal to 0 now because we moved everything over. Now at that point, we have to try to factor it, and we should think about a greatest common factor, but I don't think this one has that because the 7 here is prime, and 7 does not go into 18, for example. Now after that, we'll try to just use the trial and error method. So I'll go ahead and break it up into two parentheses. I'll think about factors of 18 that I can use. So maybe I'll try, for example, 3 times 6. So I'll do 6x and 3x. And then because it's positive here on the right, it means we'll have 2 of whatever sign is on the left. So I'll use 2 negatives, for example. And then we'll think about how to put the 7 in so that we might end up with a result of 45 as the middle term. Now if I put 7 here and 1 here, we can check the middle term and see that we get minus 3x. And then we end up with minus 42x. And when I add these together, I do indeed get minus 45x. So that's the proper factoring. Okay, once I know that's factored properly, we're going to use something called the zero factor property. So that means we're going to take each of these factors and separately set them equal to 0. Because what the zero factor property says is if you have two things multiplied, like we have here, and the result is 0, it must mean that one or both of the items or terms are equal to 0. So that means either 6x minus 1 is equal to 0 or 3x minus 7 is equal to 0. So that's applying the zero factor property, setting the factors separately equal to 0. So remember, if two things are multiplied and the result is 0, it means one of the two factors, or perhaps both, are equal to 0. Okay, so to solve this is very easy. We move the 1 over to the other side. We have 6x is equal to positive 1, and then we divide both sides by 6. And we end up with the answer x is equal to 1 over 6. And then we do the same over here, move the 7 over. We'll have 3x is equal to 7. And then from there, we'll divide both sides by 3. And of course, we end up with the answer x is equal to 7/3. All right, so those are our two solutions to the quadratic. And then, of course, if we want to, we can go ahead and check the solutions. But I'm going to assume that these both work. All right, from here, let's tackle example B. So for example B, we're going to first want to distribute the 3 into the parentheses to remove the parentheses. This is going to have another benefit, which is that it'll remove the fraction for that second term there. So if I do 3 times x squared, I'll end up with 3x squared. But if I do 3 times negative 5/3, the 3 and the third will cancel out. So I'll simply end up with negative 5 there. And then we'll have equal to 2x, right? So again, the 3 cancels with the 1/3, leaving me with just negative 5. So it's a really nice thing to distribute in the 3 in this case. Now again, I see that this term is squared, so I'm going to go ahead and move everything over to one side, assuming that the equation is quadratic in nature. So I'll move over the 2x, and we'll end up having 3x squared. When the 2x comes over to the left, it becomes negative 2x. That'll have minus 5, and all of that will be equal to 0. So I brought all the terms to one side. Now we have to try to factor. Looking at a GCF, I don't see one because 5 is prime, and 5 doesn't go into any of the other coefficients. So we'll just try to factor this by splitting it up into two parentheses. So we can break 3x squared up as 3x and just 1x. And then for the 5, we can split it up as, for example, 5 and 1. And when we check the middle term, let's see if it would give us a difference of 2. So this would be 5x, and 1 times 3 would be 3x. Now, the difference there between these two things would be 2x, but we need to make sure the signs are set up so that we end up with a negative answer for the 2. So let's make the 5 negative and make the 1 positive. We know it has to be a sign of each because remember, when it's negative on the right-hand side, it means we have a sign of each in the parentheses. So we end up with negative 5x and then positive 3x. This way the difference ends up being a negative 2x. Okay, So it looks like we have everything done there. So let's go ahead and use the zero factor property now. So remember, whenever you have two factors that multiply to give you 0, it must mean that one or both of the factors are equal to 0. So we can solve that by saying 3x minus 5 is equal to 0, or x plus 1 is equal to 0. Then moving this over, we'll get 3x is equal to 5, and then of course dividing by 3 both sides, we end up with the idea that x is equal to 5 over 3. For this one, it's a little simpler. We just subtract 1 from both sides or move the 1 over to the other side, making it negative, and our answer is simply x is equal to -1. And those are your two solutions for the quadratic in example B. All right, so last example is example C. And to solve this one, we notice that it actually starts out with sort of rational expressions here, right? So the terms are rational, meaning they're fractions, and we have to sort of turn it into something that doesn't have these denominators. At least that will probably be the simplest way to solve it. So what I'm going to do is look for the least common denominator, and I'm going to multiply every fraction or term in the problem by that LCD. So the LCD here would simply be y minus 2 times y plus 4, because remember, we take a factor of each and we simply multiply them together. And then we put the largest exponent we see on each factor, but each of these factors is only to the first power, so we just have the LCD y minus 2, y plus 4. All right, let's multiply every fraction by that LCD. I'm going to draw a long kind of numerator here, just to make sure that we have room to put the LCD in. So just rewriting the problem, kind of giving myself space to put in the LCD. So I'll pencil in the LCD, y minus 2, y plus 4, and y minus 2 times y plus 4. And then lastly, y minus 2 times y plus 4. Okay, so every term got my LCD. Now we do the fun part, the canceling, right? So cancel out the y minus 2 there, cancel out the y plus 4 here, and nothing can be canceled in that last term. So we'll end up having 3 times y plus 4 is equal to 5 times y minus 2 minus 4 times y minus 2 times y plus 4. All right, from here, let's go ahead and distribute. So we'll bring in the 3 here, for example. We'll say 3y plus 12 is equal to 5y minus 10. And then let's keep the minus 4 outside and first FOIL these two binomials. So we'll have y times y, which gives us y squared, and then y times positive 4, which gives you plus 4y. Then we'll have minus 2y, and then finally minus 8. Then we'll have 3y plus 12 is equal to 5y minus 10, and then distributing in the negative 4, so we'll have minus 4y squared minus 16y, positive 8y, and lastly, negative 4 times negative 8 gives you a positive 32. Okay, let's go ahead and combine like terms. So on the left-hand side, there's nothing alike, but on the right-hand side, we have some things that can go together. For example, I have a 5y, a negative 16y, a positive 8y, right? So that'll give us 3y plus 12 equals to, I'm going to write the minus 4y squared first, so I've rewritten that. Then I'm going to combine all these y terms. So negative 16y and positive 8y will give you negative 8y, and negative 8y plus 5y gives you negative 3y. Then from there I have negative 10 and I have positive 32. It's going to give me positive 22. Okay, now we have a quadratic equation because I can see that this term here is squared. So let's bring everything over to the left-hand side of the equation. So I'm going to bring over my negative 4y squared, and when I do that, it's going to become positive 4y squared. Then I'll have plus 3y plus 12 is equal to minus 3y plus 22. Now I'm going to bring over my negative 3y and over my positive 22. When I do that, I'll end up with 4y squared plus 3y minus 22 plus 12. And all of that will be equal to 0. So continue to rewrite 4y squared. If I add together 3y and 3y, I get plus 6y. And then negative 22 plus 12 is going to give you negative 10. And all of that is equal to 0. All right, now we finally can try to factor. I see a GCF here in this problem. So I'm going to factor out 2 because I think 2 is in common to all the terms. If I divide 2 into 4, I get 2. That'll give me 2y squared. 2 into 6 will give me 3. That'll give me 3y. And 2 into negative 10 will give me negative 5. And all of that will be equal to 0. I can divide off this greatest common factor. I can divide it into both sides. We're always allowed to divide the left-hand side of the equation by whatever I want, as long as I do the same to the right-hand side. So when I do that, this becomes 1, and that, of course, remains 0. So we have 2y squared plus 3y minus 5 is equal to 0. Now we can factor. So we'll draw our two parentheses, and we'll say 2y and 1y. And then we have factors of 5, and we know that we'll have to have a sign of each inside the parenthesis. So let's go ahead and put the factors of 5 so that we end up with 5 here and 1 here, and we'll make the 5 positive and the 1 negative. So let's see what happens if I check the inside term. We'll end up having 5y positive, right? And then we'll have a negative 2y. So of course when we add these together, we do get the 3y in the center that we're supposed to have. All right, let's apply the zero factor property then, which says, look, if we have two things multiplied and the result is 0, then it means that one or both of these terms are equal to 0. So when I solve this one, I end up getting 2y is equal to negative 5. And then if I divide both sides by 2, I get the answer y is equal to negative 5 halves. And for the other one, if I move the 1 over to the side, I simply get that y is equal to positive 1.